Hello, everyone. So in this video, we are gonna try using Pascal's triangle and binomial theorem to expand the fourth power of this binomial. So the first thing we are gonna try, like remember the Pascal's triangle is a triangle that we get by adding the numbers on like rows together to get the next number. So in this case, we are given some of the rows already. So what we do is we just like write the ones in each side. So let's say this is one and this is one. And then we add one and two. So that is three. So two and one, that is three. So we just continue having those ones. 1, 3 add up to 4. 3, 3 will be 6. 3, 1 is 4. You just keep doing this until what you want, okay? So this is the row number 3. Okay, so and then the next one is row number, maybe I should write this way. So row number 3, and then this is row number like 4. These numbers on the Pascal triangle actually will give us the coefficient of this expansion. So what does that look like? We have the fourth power of the difference of two terms, right? So our first term is 2z. The second term I can take as negative 3k. So because I just like to write a sum of two expression. So which can be written like 2z plus negative 3k. So that is gonna be my two terms to the fourth power. So when we do this, like we may use a Pascal's triangle, especially if the power is not too big, which is in this case is not too big. So how we do that? We just look at the row number that is matching with the power of a binomial, which is these numbers. So we start with 1. That's my first term, right? And then I'll just kind of write the next like number. Like this is our like the coefficient is 1. Now we are going to take the first term, which is 2z, and we take the fourth power of this, and then multiply this by the zeroth power of the next term. But the zeroth power is just 1, so we don't need to worry about it. And the next coefficient is 4, so I'm going to go with like 4, and then times my the first term was 2z, so that will be 2z. But now this will have the third power. And my second term is negative 3k. And that will have now positive first power. So this like was 4, now is 3. So the power of the first term decreased by 1, while this was like negative 3k to the zeroth power, but now it's the first power, so it increased by 1. And we just keep doing this process. And the next one is like we have 6. So I can write those coefficients to make it a bit faster. So that's 4, and then this is 1. And these are my coefficients, right? So that is like 2z to the second power, and then negative 3k to the second power as well. And then plus, so 2z, 4 times 2z to the first power, and then negative 3k to the fourth power. And the last one will be like, we got 2z to the zeroth power, which we do not need to write it. So negative 3k to the fourth power. As soon as we have this, it looks like a bit much work, but we are going to simplify this. Like we have 2z to the fourth. So 2 to the fourth is 16. Z to the fourth is z to the fourth. So 16 times 1 is just 16. So I'm going to go with 16 z to the fourth. And the next one is 2 to the third, which is 8. And z to the third is z to the third, but 8 times 4 is 32, so we'll get 32 from there. But at the same time, we have negative 3 as well, so we multiply these numbers, 4, 8, and negative 3. So if you multiply 32 by negative 3, which is going to be 96, so that should be 96. And z to the third power, because we have z to the third, and then k to the first power. And the next one has 2 squared. 2z squared is 2 squared will be 4. And then you got negative 3k, which is going to be squared. So that will be negative 3 squared is 9. So 9 times 4 is 36, right? And then we multiply that by 6. Maybe I can just multiply those. So on the side. So we have 6, we have 4, and we have 9. but these are all positive, so be aware this is even power. So I can just say 6 times 36. 6 times 3 is 18, which is 180. 6 times 6 is 36. 180 plus 36 is 216. So that will be 216. And the power, we have the z to the second power. So we just have z squared and k to the second power as well. Okay, so we are done with this term. Now we have the other terms. So I'm gonna kind of continue right here. So like this one has like 4, and then 2 times z, which is 2. And then there is like -3 to the 4th power, which is gonna be 81. And then z to the first is just z, right? And then this is k to the 4th, and that will be k to the 4th. And then the last one is -3 to the 4th. I think I missed right here. This has to be 3, not this one. So if I change this one, so that should be 3rd power. So that means this is gonna be 2, this is 4, this is -27. And then that will be z, k to the 3rd. And the last one will be -3 to the 4th, which is gonna be 81. And then k to the 4th power. And if I just simplify this a bit, so I will get 16 z to the 4th and 96 z cubed k, and then plus 2016 z squared and k squared. And then you have like 8 times this number, so which we can simplify right here. So that should be 8 times -27. So if you just multiply these, we are gonna end up getting these guys. Okay, so let's see what we have now. Okay, so as soon as we have this, like we just multiply these, right? So this is just 8 times -27. So this was like 4 and 2, so this should be a positive. And 8 times 2 is 16, so that will be 160. And then 8 times 7 is 56, so that's gonna be 216 as well. Let me double check. 160 plus 56, so I think, yep, that looks good. And now we have like -216 and z k cubed, and then 81 at the end with k to the 4th. So I can just leave it as this because I got my coefficients, I got my terms. So only thing is I just want to say we have z to the 4th, z to the 3rd, z to the 2nd, z to the like 1st, and z to the 0th. And this is k to the 0, k to the 1st, k to the 2nd, k to the 3rd, k to the 4th. So that is the changing of your exponents for each variable as you go from left to right. So as long as you keep that order, so you shouldn't be confused that much. And then these numbers like 1, 4, 6, 4, and 1, those are my coefficient that is coming from the Pascal's triangle. But you know, this is okay, especially if you are doing like 4th, 5th, maybe even 5th, 7th power and stuff. You can just make your Pascal's triangle and use those coefficients and simplify after, which is possible. But there is another way what you have, which when we kind of have it more powers, like larger values of this part, this may be not a good idea to use the Pascal's triangle to get those coefficients, which is why we're going to use the combination, and then we are going to have a expressions called binomial theorem. So I'm gonna do as our second approach as well. So to do so, let me clean this first. Okay, so I need kind of a bit more space. So if I wanna use the binomial theorem, so it is kind of straightforward, but here's what we are gonna start with. So we are gonna start with this guy 4, and then we just say 4 choose 0. And then that will be my coefficient times. My first term is 2z to the 4th power. And then I don't need the -3k to the 0th. And then now we have 4 choose 1. So we start with 0, now it's 1. And then 2z to the 3rd, and then -3k to the 1st power. And the next one is like 4 choose 2 times 2z to the, this was the third power, so we should have second power. And then we got negative 3k to the second power. And then 4 choose 3. And then times 2z to the first power, and then negative 3k to the third. And the last term will be 4 choose 4 times negative 3k to the fourth power. So this is exactly what we're going to start with. As soon as we have this, we just need to find their like values, like 4 choose 0 is equal to 1, 4 choose 1 is 1, 4 choose 2 is 6. So you can just kind of remember how we do it. So you can use the formula for each one of these. So like the formula for the combination was n choose r is like n factorial over n minus r factorial times r factorial. So you can just kind of use each one of these. So for example, for choose 0. So choosing 0 is basically none, do nothing. We just say one way to do so. And then you got 2z to the fourth power, which we already know this was 16 times z to the fourth. And for choose 1, you can say you just choose 1 out of 4, which is 4 option. But if you want to use the formula, so you will get 4 factorial over 4 minus 1 factorial times 1 factorial, which will be also 4 when you simplify. And you just keep doing the same thing. So 4 choose 2 will be 6. So again, this is going to be 4 times something. And then this is going to be 6 times something. 4 choose 3 will be 4. And then times something. And the last one, 4 choose 4 will be 1. So what I'm trying to show, these numbers that we are getting from the 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, all the way to 4 choose 4, they are actually the numbers that we had in the Pascal's triangle. So without really having that Pascal triangle written, so we can just get this by using combination. So which is we call this expression is binomial theorem. There is a short way of writing this, which looks like this. So we use the sigma notation, and then we just start with like n choose r. R is just anything, so that I can start with r equals like 0, because when you choose 0 for r, that's what you got. For choose like 0, and then you will continue all the way to the end, and that's going to be equal to x to the nth power minus r, whatever that number is, times y to the r power. So in this case, like if you choose 0 for r, so that will be n choose 0 and y to the 0th power, which will give us the first term. And if I choose 1 for r, I just replace that. That will be the second term. And then this is called binomial theorem. So it's just the compact way of writing this entire thing. But this is going to be useful when we are trying to find the middle terms as well. Okay, without really expand the entire thing. So I hope that was clear. So we can just use the binomial theorem or Pascal's triangle to get the coefficient. As soon as we have the coefficient, we can just expand to some simplification. So that's what we do either way. Okay, I'll see you in the next video.